Hello everyone, my name is Jiancong Chen. I'm currently a PhD student at UC Berkeley. The title of my project is Cause and Effect, Temporal Variability in Climate Forcing and Ecological Responses at East River Watershed, Colorado. So this work is originally motivated by the fact that gradual change in climate is altering water and energy balances, which will further reshape ecological responses in vulnerable mountainous watershed. So understanding the complicated cause and effect linkages among climate forcing and ecological responses is of great significance for us. In order to provide long-term, large-scale monitoring of ecological responses such as evapotranspiration, we're always facing a problem that we do not really have information or data. So here I'm also developing a hybrid predictive model which is capable of going from point scale to larger scale. In terms of the research side, I'm mainly focusing on the East River Watershed, which is managed by Lawrence Berkeley National Lab. And there are currently different types of data that are currently being incorporated into my model and development analysis. For example, climate forcing data from snow tell stations and also daymat, and also vegetation indices that we can calculate it from remote sensing images such as Landsat. In terms of the methodology, there are different types of statistical analysis that are currently being employed in my model, including principal component analysis and also hidden Markov model. And the hybrid predictive model mainly includes two parts, where we have a well-developed physically based model, and in my case, it's the community lab model, and also a deep learning module, which is long short-term memory. So by establishing the relationship or the linkages among ecological responses and also the climate forcing, then we can learn the corresponding physics by using statistical or machine learning methodologies. And then we can use this model that we learned from this one location to make predictions for other locations. In terms of some of the preliminary results, first I'm showing HPM performance. And this HPM is originally trained by using the information or data from build station, which is here. And then after we are able to establish the corresponding linkages among ET and climate forcing, then we can use this model to go for other two locations, which are SP and PK. And by comparing the results of HPM to the corresponding CLM model for those two other locations, we can directly see that the model fit is really good, so indicating that HPM has significant potential to provide us long-term and large-scale monitoring. In order to understand the cause and effect linkages among climate forcing and ecological responses, here I'm presenting a three-stage hidden Markov model results. So we can directly see a whole year of 2008 are currently being classified into different short periods of time. And each short period of time is associated with a set of dominant processes. So by knowing the change or the regime shifts among those dominant processes, we are really able to delineate the complicated cause and effect linkages among them. Last figure showing on the far right, and then which is basically some of the implications by incorporating a HPM model output and also relating this information with the hidden Markov model results, then we can directly see that the greatest increasing gradient of evapotranspiration is actually at the time periods where we have the snow amount occurring. That information is also related with the short period of time indicated from hidden Markov model. And if we look at the post-summer and autumn behavior of evapotranspiration dynamics, the general decreasing trend is following the solar radiation trend, indicating this is energy limiting conditions. But if we compare the fast and short temporal variations of evapotranspiration in this time periods, it actually is following the precipitation patterns, indicating the rapid growth and dying of vegetation. So by using all of those information available, we are able to first decouple the whole time series into a short period of time, and then find the corresponding linkages among climate forcing and ecological responses. So in conclusion, first, HPM is capable of incorporating information from different types of data, including remote sensing and also climate forcing, which enables us to go from point scale to larger scales. And also the complicated HMM model and the statistical analysis are capable of providing information of the cause and effect linkages among climate forcing and ecological responses. That's the end of my VPS presentation. Thank you for listening.